Okay, so today we're going to learn to model a simply supported beam. We're going to model this simply supported beam. This beam has a span of 10 feet and here's the cross section. The beam's cross section is 10 inch by 20 inch and the material properties of the beam are given here. The strength of concrete is going to be 3.5 ksi and the steel strength is going to be 60 ksi, meaning it's a 60 grade steel. Okay, so let's go to ETABS. Now we need to take a new model. So there are many ways to do that. You can go to a new model from here, or you can click here for a new model, or you can go to file, then click new model, or you can press Ctrl N to get a new model. Okay, so when you click the new model, then a window will pop up. A window of this kind will pop up. The first option says use saved user default settings. So this option is for a default setting that we have saved previously. So we're not going to be using that because we don't have any previously saved default settings. Then use settings from a model file. If you have modeled a file before and you want to use the same settings for this model as well, then you can use this option. Or we don't have that right now, so we're going to be using use built-in settings with. In this option you can freshly take the settings. Okay, so if you want to know more about these two options, you just need to hover your mouse over here and a window will pop up, some kind of a window that will tell you about these things. So display units, we're going to be taking we have three options: metric SI, metric MKS, and US customary. We're going to be using US customary because the length and the cross section is given in feet inch. Okay, so we're going to be steel section database. We're going to use AISC 2014, and then steel design code, we're going to be using this code. We're not changing the code, but you can change the code according to your need. Then concrete design code ACI 31814. I'm using ACI 31814. You can use other available options from here, and you can also hover your mouse here to see the units. So US customary units are going to be giving us these units for these items, and if we had chosen metric SI, then we would have gotten these units for these items. We're going to be using US customary. Okay, now we have to decide on our grid. So number of grid lines in X direction. So we need to give the number of grid lines in X direction. To do that, we need to understand a few things first. So this is the axis system of ETABS. The Z axis is vertical, the Y and X axis are the plane axis. So our beam is actually lying on the X axis, so its length is in the X direction. So if you want to draw the grid lines, then let's take a color, let's say green. So since the length of the beam is in X direction, so if you want to take two grid lines that will define the total length of beam, then we need to take two grid lines, one here on this support and another one on the other end of the other support. So we're taking these grid lines along X axis. That means that the spacing of the grid lines is going to be the spacing in the direction of X axis. Okay, so that would mean we would need to take two grid lines along X axis. The number of grid lines in X direction is going to be 2, and from here we can see that there are no grid lines required in Y direction. So we're just going to give it 1. Okay, just one line. The one line is going to be actually we're just taking one line, but it doesn't actually matter. So let's go to ETABS again, and the spacing of grid lines in X direction. Since the beam length is 10 feet and one grid line is here and another grid line is here, that would mean the spacing between the grid lines is 10 feet. So we're going to give the spacing as 10 feet. Then spacing of the grid lines in Y direction, we don't need to touch that because there's only one grid line in Y direction. Then we're going to go to story dimensions, simple story data. number of stories, we're just going to take 1 because this is a building or any kind of a structure. We're just going to model a beam, so number of stories 1 is appropriate. Typical story height, bottom story height, we don't need to edit any of these because we're not working with a building structure here. Then we'll just take grid only and click OK. Once we do that, we'll see 2 windows here. One window is going to show us the 2D view and the second window is giving us a 3D view. So right now I don't need the second window, so I'm just going to close it. We can open it later. I'll show you how to do that. Now if you scroll your mouse, then we'll zoom in and zoom out. We're going to take, this is actually our plan view. We're going to take elevation view, elevation 1. Okay, so this is our elevation view. So from what we have known that this height along z-axis is 12 feet since we didn't change the story height. This is 1 story height, and this is our dimension A to B. From A to B it's 10 feet long. So A point is the first grid line in x direction and B point is the second grid line in x direction that we have taken. So now once this is done, we need to define our material properties and then we need to define our section property. So let's go to ETABS. Here's the define option. You just click here and go to material properties. As you can see, there are previously given material properties. We can either edit them or modify them, or we can create new material. So we're going to create new material. Let's try creating new material. Region. Region is going to be user because I'm from Bangladesh and none of these countries matches mine, so we're going to take user. Material type is we're going to first define the concrete, so I'm taking concrete. Alright, concrete. So material name, so we need to give the material name in such a way that we can recognize the material properties. So it's going to be 3.5 KSI. So the material type is concrete, then material display color is red. Let's change the color from red. We don't want the red color because the red color is given for failure. So we'll try to avoid the red color. The material types, then we have material weight and mass, unit weight per unit volume of concrete 150 pound per feet cube. We're using normal weight concrete, so it's alright. Now modulus of elasticity. We need to fix the modulus of elasticity. The modulus of elasticity given here is for 4 KSI concrete, but our concrete is 3.5 KSI. So we'll just give the ACI formula here, 5720 into, we have square root of the value here has to be given in pound per square inch. So we're giving pound per square inch, 3500 there. So this is the modulus of elasticity for our desired section property, material property. We'll just change the name here, specified it's going to be 3500. Okay. Then okay, so our material, concrete material is defined. Then add new material. We'll go to the steel, but we don't need to define the steel because 60 grade steel is already here. Okay, so now let's go to defining the section. Let's choose the frame section. We can see that there are many sections are here already. These are all steel sections. We do not need any of these sections, so we can delete them. Okay. So we're just going to press on delete property. Delete multiple properties, and we're going to select all of these and we're going to delete them. Then again, okay, delete. Sections, and then we're going to delete all of this. We just need to keep one here. Okay, so the properties are deleted. Now we're going to add our own properties. So we can see here the section shapes, the concrete shapes, the steel shapes, the special shapes, and the steel composition shapes. So our concrete is a rectangular beam, so we're going to choose the square shape or rectangular shape. There we go. We have to give the property a name. Let's give the name 20x10 since it's a 20 by 10 beam. Now material property, we're not going to use the 4000 psi concrete, we're going to use the 3.5 psi concrete. So we're going to choose the material that we have defined before. Then the section shape is concrete rectangular, we're going to keep it at that. The depth of the concrete is going to be 20 inches and the width of the concrete is going to be 10 inches. Okay, so we're going to modify the rebars reinforcement. Okay, the design type is now given a column. We're going to change it to beam. Now top bars to bottom bars, the distance of top bars to bottom bars. Well, we need to discuss this. Okay, the distance required is actually from the outer portion of the concrete section to the main rebar's center. So the clear cover is 1.5 inches, and then the tie bar we're using is the number 3 bar. That would mean it's 0.11 inches square. The diameter, then we're going to add the diameter 0.11 inches to 1.5, so 1.5 plus 0.11, and the bar we're going to be using is going to be a 90mm bar, which would mean its diameter is going to be roughly 0.31. The radius is going to be 0.31. So if we add that up, it's going to be 2.3 inches, but we're keeping it at 2.5 inches because 2.3 inches is easy. If we write it here, it's easy to write, it's easy to model, but when we're going to actually construct the beam, it's going to be hard to get a 2.3 inches. So let's keep it at that. So our section is ready as well. Okay, now we're just going to draw the beam. To draw the beam, we're going to choose this draw option here, draw beam or column brace. Then after that, window will pop up here, the property. We're going to change the property to our desired 20x10, the one we just made. Then we're going to draw it here. So we're going to just put our cursor here at the first point. When the grid point shows, we're going to click it. And then we're going to take our mouse to the next point. Here it's showing the distance 10 feet, and when the point snaps, we're going to click it again, and then to release it, we're going to right click. Okay, so we have our beam drawn here. Let's choose the mouse again. Now we need to draw the supports. So I'm choosing the point here and selecting the point here, then we'll go to assign, join, restraints. We're going to choose the hinge support here, then we're going to apply it. So the hinge is applied here, then I'm going to choose this point, and then we're going to apply the roller support. Using the roller support, then press apply, and okay. So our beam is ready. So you can see the section of the beam. You can go here, and then you can turn on section properties. Go to object assignments, and then we turn on sections and apply. Okay, so you can see the section property of the beam here as well. So our modeling is almost complete. If you want to see the 3D now, you'll just go and window list, click on the window list and press on add new window. So the 3D view is here. So we're going to choose the 3D window here, and then we're going to click here the extrude view option. So you can see that it's not extruding, so I'm going to choose the draw option. Then I'm going to choose the mouse option once again, and then I'm going to choose the 3D option and give extrude again. So the beam is extruded. You can see the beam in 3D view here. See that? So our beam in 3D view. Let's try seeing it in rendered view. Go to view, and here show rendered view. So this is our rendered view of the beam. This is the rendered view of our beam. So you can see our modeling is complete. So this was all for this video. I'll see you guys in the next video. Thank you for watching.